In this lecture, we will discuss about the stability of a partially submerged body. So you can see here uh, this body. So this is floating here, and you can see the center of buoyancy here, and center of gravity is here. That means center of buoyancy is just below the center of gravity. At the center of gravity, weight of the body is acting downward. At the center of buoyancy, the buoyancy force is acting upward. And this body is given a slight tilt. So what happens then? So you can see this vertical axis passing through the earlier buoyancy point and gravitational center of gravity. Now when it is given a tilt, the center of buoyancy will shift towards right because more fluid is displaced in the right portion. So this is B1. And if you draw a vertical line through this point, that is a buoyant force, the vertical line showing the buoyant force, it will intersect the earlier line at this point, and this is called the metacenter, as we have discussed earlier. Now, see, now the weight of the body is acting to the center of gravity, and the buoyant force is acting through the center of buoyancy. These two forces, you can see that it is not it is a distance apart. This causes a moment. So that means it will be like this. This will cause a moment that is the anti-clockwise direction. So because of this moment, this body will come will come to its initial position, and that is called a stability. Stability means when the body is given a tilt, it should come back to its initial position. So because since this is the moment created, that is anti-clockwise moment is created, it will come back to its initial position. Similarly, when the body is given a leftward shift, when it is tilted to the left side, a clockwise moment will be created, which causes the body to come back to its initial position. So that is why it is called the body is stable. That is why the body is stable, and this is called stable equilibrium condition. And let us see an unstable equilibrium condition. So you can see the body. So the center of gravity here, center of gravity is little upward, and center of buoyancy is here. So in this case, when it is given a tilt, the new center of buoyancy is B1, and the metacenter will be here. The metacenter will be here. So just look at the forces. The buoyant force is acting at B1, and gravitational force is acting at G. So let us see the couple that is created. You can see that the couple created is in the clockwise direction, and this clockwise moment will cause the body to tilt rightward. It will not come back to its initial position, initial stable position. So this body is said to be unstable. So this condition is the unstable equilibrium condition. For the stability of the partially submerged body, the condition is metacentric height should be greater than 0. So in the earlier case, you can see that Gm, that is positive. In this case, the metacenter is below the center of gravity. So that means in this case, Gm is less than 0. So the body is unstable. In this case, Gm is greater than 0. So the body is stable. So this is the condition for the stability of a partially submerged body. Now let us see the stability of a fully submerged body. What is the condition for the stability? You can see here the left side, the figure, this figure. So the center of gravity is here and the center of buoyancy is here. So the weight is acting downward at the center of gravity, that is W, and at B, the buoyant force is acting upward at B. And just like the earlier case, we are giving a tilt to this body. So when it is given a tilt, the center of gravity will remain here and center of buoyancy will be shifted towards rightward. A little center of buoyancy will be somewhere here. So if you draw the forces FB and W, so the forces will be like this, FB and W. This will cause a couple which will tilt the body back to its initial position. That is, it is creating an anti-clockwise moment. So this is called a stable equilibrium. That means the body is coming back to its initial position. So the body is stable. If the body is given a tilt towards right, it will come back to its initial position. Similarly, if the body is given a tilt towards left, it will come back to its initial position. So the condition is the center of buoyancy should be above center of gravity for a fully submerged body to remain stable. Let us take an unstable equilibrium condition. Here the center of buoyancy is below the center of gravity. So the weight is acting downward at center of gravity and buoyant force is acting upward at the center of buoyancy. So when it is given a tilt towards right, you can see that there is not much change in the position. So when it is given a tilt, the center of buoyancy will be acting here and center of weight is acting downward here. So this will cause, you can see that this force will create a clockwise moment, which will further cause the body to tilt rightward. It will not come back. That means the body is unstable. For a body to be stable, it should come back to its initial position. So you can see that the condition for stability is center of buoyancy should be above center of gravity. Now let us take the case of a neutral equilibrium. In neutral equilibrium, you can see that both center of gravity and center of buoyancy are at the same point. That means there is no couple created here. So it is said to be a neutral equilibrium. So we see that for a stability of a fully submerged body, center of buoyancy should be above center of gravity. So this is the condition for a full stability of a fully submerged body.